Welcome to Study Loop.
So before anything, we can write two equations that describe the angular displacement of disk A and disk B. So for disk A, we can say that theta sub A would be equal to the angular velocity of A times t, where the disk A is moving without any angular acceleration. And disk B, we can say that theta sub B would be equal to 1/2 alpha sub b t squared. And so for part A, when we want to find the time when theta sub A equals theta sub B, we can say that omega sub A times t would be equal to 1/2 alpha sub b t squared. So essentially, t would be equal to 2 times omega sub A divided by alpha sub b. This would be 2 times 9.5 radians per second divided by 2.2 radians per second squared, and t is equaling 8.6 seconds. Now, for B, we can find the difference in angular displacement, delta theta. This is equaling theta sub A minus theta sub B, and this is equaling omega sub A times t minus 1/2 alpha sub B times t squared. And this is going to equal 9.5 t minus 1.1 t squared. Now, for the reference lines to align momentarily, so when I say momentarily, I just mean at a certain instant in time, we only require that delta theta, or the change in angular displacement, equals 2 pi times n, where n is an element of the set of all integers. So this notation just means it is an element of, and then the z with the extra line, I suppose, that just simply means the set of all integers. So we can say that if we were to, this is essentially 9.5 t minus 1.1 t squared equaling 2 pi n. This is a quadratic equation. So you can use the quadratic formula to solve for t sub n. And this would be equal to 9.5 plus or minus the square root of 9.5 quantity squared minus 4 times 1.1 times 2 pi n, all divided by 2 times 1.1. And at this point, we can solve, or rather simplify a bit, and say 9.5 plus or minus the square root of 90.25 minus 27.6 n divided by 2.2. If we say that we want to find the solutions for TO, this simply means that n equals 0. And the solutions for T sub O would be 0 seconds and 8.63 seconds. 8.63 seconds aligns with our answer from part A, and t equals 0 seconds makes sense because initially at that specific instant in time, they are aligned. T equals 0 seconds simply means the moment when both disks just begin to rotate. Just begin to rotate at the same time. Therefore, of course, at that instant, they would be aligned. So these two solutions make sense, and we can solve for t sub 1, t sub 2, and t sub 3. And we then know that if we do solve for these 3 more values, 2 solutions exist for n sub 0, n equals 0, n equals 1, n equals 2, and n equals 3. So for all of those n values, two solutions exist for when essentially the two reference lines for the two disks align momentarily, again, at that instant in time. So essentially, this would be your full answer. That is the end of the solution. Thank you for watching.